Today we're going to do section 10.1, which is about circles and properties of tangents. So we're going to start with the definition of a circle. A circle is the set of all points in a plane that are equidistant from a given point, called the center of the circle. Circles are always named by their center. So the circle to the right here is called circle P, because P is the center of the circle. The notation we use is a little circle symbol with a center in the middle and a capital letter for the center. So we have circle P. The first segment of a circle that we're going to talk about is the radius. The radius is a segment whose endpoints are on the center and any point on the circle. So to draw a radius, we're going to start at the center, and we're going to go to any point on the circle. We can name this point A. So segment PA is the radius. The next segment we have is a chord. A chord is a segment whose endpoints are both on the circle. So we have two endpoints on the circle. We can name our endpoints B and C. And if we connect our endpoints, we form a segment BC, which is the chord of a circle. The next segment we have is a diameter. The diameter is a chord that contains the center of the circle. So because it's a chord, that means that both endpoints are on the circle. The only difference here is that it has to go through the center of the circle. So P has to be a point on the line. So we have P. We can have an endpoint D and an endpoint E. So our diameter goes from endpoint to endpoint, but has to go through the center of the circle. So segment DE is the diameter. So those were our three segments. Now we're going to move on to lines. So the first line we're going to talk about is a secant. A secant is a line that intersects a circle at any 2 points. So we have a line that intersects the circle at 2 points. We can name these points G and H. So we can say line GH is a secant. Remember, a secant intersects the circle at any 2 points, but because it's a line, it doesn't stop at those 2 endpoints. We show the arrows to show that it goes on infinitely in both directions. The last one we have is a tangent. A tangent is also a line in the plane of a circle that intersects the circle at exactly 1 point. So we have 1 point of intersection for our tangent. We can name this point M. And our tangent line is just going to intersect the circle at that 1 point. It is a line, so we have to put arrows at the end to show that it goes on infinitely in both directions. If we name another point on this line, we can name it N. We can say that line MN is a tangent. It's also important to note that point M, where the tangent intersects the circle, is called the point of tangency. That's our point of tangency. All right, if we take a look at example 1, we want to classify each line, ray, or segment as a radius, chord, diameter, secant, or tangent of the circle. So I would like you to pause the video and try example 1 on your own. If we take a look at AC, AC has endpoints on the center and on the circle, so we can classify AC as a radius. Segment AC is a radius. Next, we have segment AB. Segment AB has endpoints both on the circle, but it intersects the center of the circle. Because it intersects the center of the circle, we can classify AB as a diameter. Next, we have CB. CB again has endpoints on the center and on the circle, so we can classify CB as a radius. Segment CB is a radius. Next we have segment AG. Because it's a segment and both endpoints are on the circle, we can classify AG as a chord. Next we have line AE. So line AE, because it's a line and it intersects the circle at 2 points, at point A and point G, we can classify line AE as a secant. And lastly, we have ray DE. Ray DE goes on infinitely in one direction and only intersects the circle at one point, which is point B. So we can classify ray DE as a tangent. I would also like to point out that point B is the point of tangency. And that C is the center of the circle. If we take a look at number 2, we want to use the diagram to find the radius, the lengths of all the radiuses of the 4 circles, and the diameters. So to find the radius, we have to go from the center of the circle to an endpoint on the circle. We can see that the radius of circle A is 3 units. I would like you to pause the video and find the length of the radius for circle B, circle C, and circle D. So the radius for circle B is 2 units, circle C is 3 units, and circle D is 2 units. Now we're going to move on to find the lengths of the diameters. So the diameter, remember, has endpoints both on the circle, but it goes through the center of the circle. So the diameter of circle A is 6 units. I would like you to pause the video and find the diameters of the 3 remaining circles. Circle B has a diameter of 4 units. Circle C has a diameter of 6 units. And circle D has a diameter of 4 units. So as you can see from the lengths that we found, the diameter of a circle is twice as long as the radius. The diameter of a circle is twice as long as the radius. Next we have coplanar circles. These are circles that are in the same plane, and they can be drawn 3 different ways. They can have 2 points of intersection, 1 point of intersection, or no points of intersection. So to draw 2 circles with 2 points of intersection, we have 1 circle, and we have a second circle, and you can see that they overlap or intersect at 2 points. So A and B are the 2 points of intersection. Next we have 1 point of intersection. So this can be drawn 2 different ways. We can have 1 circle and then another circle outside of that circle where they only intersect at 1 point. So A would be our 1 point of intersection. We can also draw our circles with 1 point of intersection inside one another, so one inside the other. So we can have 1 circle and then another smaller circle that goes inside the larger one where they only intersect at 1 point. So here A and B are our single points of intersection. And then last but not least, we have our coplanar circles with no points of intersection. So we just have 1 circle. I don't know why it looks like that. So we have one circle and then another separate circle right here. All right. Sorry about this. So here we have two circles with no points of intersection.